X and Y plane make the Cartesian coordinate plane. They're like two rulers on the plane. Now a coordinate, or a point on the plane is given by the ordered pair x, y. It is going to tell us where on the graph to find a point. We go over x and up y. Alright, so if we have 2 points on the plane like these, we can then graph a line between them, or a line segment. That line segment will have some sort of length or distance, and we can use the distance formula to calculate that length. Where did that come from? The distance formula is really the Pythagorean theorem, and a squared plus b squared equals c squared is really the run squared plus the rise squared equals the hypotenuse squared, or the distance squared. So when we use the coordinate geometry form of the Pythagorean theorem, we get the distance formula. So again, if we have 2 points on the plane, x1, y1, and x2, y2, then we can find the middle of that line segment, the point that lies exactly in the middle that cuts the line segment exactly in half. That's called the midpoint. We usually use a capital M to denote the midpoint. Now, it's easy to find the coordinate of the midpoint if you know those two endpoints. Alright, so really what it is just taking the average of the x values and the average of the y values and giving you your new coordinate. Okay, so recall that the run is the difference in the x values and the rise is the difference in the y values. And if we take the ratio of the difference of the y values over the difference of the x values, we get what's called the slope of the line segment between the 2 points. Change in y over change in x, rise over run, little m. These are all things that we use to denote the slope. And it's all due to the right triangle that we build on the coordinate plane there. The rise and the run are the legs of the right triangle. So next, the equation of a line. Now the equation of a line in slope-intercept form is the most familiar. Y equals mx plus b. The m is the slope, the b is the y-intercept, and we usually call that the starting point. Go on the y-axis, find that coordinate of the y-intercept, and use the rise over the run from the slope to plot a few extra points, and then we can graph a line between those points. Something like this. The point slope form of the equation of a line is when you have a point that might not be the y-intercept. And so we'll call that x0, y0, and it looks something like this. The general form for the equation of a line, however, sometimes comes in the form of a number times x plus a number times y equals another number. And each one of these can be transformed into the other one. Okay, let's use Desmos to graph some lines. I'm going to plot y equals 2x plus 5, which has a y-intercept of 5, and a slope of 2. The next line I'll graph will be y equals negative 1/2 x plus 5. Now the reason I chose this one is because it has a slope that is the negative reciprocal of the first one that I graphed, and therefore it should be perpendicular to the line that I just graphed. I also chose a y-intercept of 5, so they'll cross each other at the y-axis. Now, next we could graph maybe a circle. A little more complicated with the equation, but nonetheless, let's graph a circle. And let's center that circle at the point of intersection of these two lines. So the equation of that that circle will be something like this. X minus 0 quantity squared plus y minus 5 quantity squared equals, and now I have to pick a radius, let's say 2 squared, so I'll have it equals 4. When we get to circle equations, you'll understand this equation a little bit better. But for now, I'm just going to graph this equation, and it's going to have a center of that intersection point 0.05. And so in purple you see here the circle, and now what I'd like to graph are two more lines. Two lines that are going to be parallel to the first line that I graphed. So they'll have the same slope as the first line that I graphed. But I'm going to make them so that they are tangent to the circle. That is, that they're only going to touch the circle at one point. Check this out. So I've chosen the y-intercepts very carefully so that those two lines are tangent to the circle. It was a little tricky. Anyway, stay tuned for the next video, and I hope you're enjoying coordinate geometry.